Welcome to another 2014 Comp1 exam programming solution tutorial. In this set of tasks we're going to be focusing on the deck, and the sort of things I've thought of were shuffles, to save a particular deck state, some of the stats to do with counting the cards, and then just have a little look about working with non-standard decks. So shuffles. This has got me quite excited, I've got to be honest. This is really, really lovely, because the current shuffle is about as poor as they could do it, while still randomising the deck. I mean, if this exam was being done in a couple of years' time, when it's the linear A level, and you've got the sort of stuff that you'll be doing in the upper sixth, you've got some really lovely tools at your disposal. But let's keep ourselves focused on the exam coming up. Let's keep it simple. There's lots of maths and computer science behind shuffling cards, whether it's cryptography or just sort of the opposite of sorting, basically. Randomisation is kind of the opposite of sorting, and shuffling is a form of randomisation. I think there are two algorithms that we will play with, or I'm going to show you because I've sort of enjoyed coding them myself. One is the Riffle shuffle, and the other one is a strategy called Fisher-Yates. I'll be honest with you, I'd never seen the Fisher-Yates one, but I was looking for a strategy that basically went through a little bit more systematically than just picking two random numbers and swapping them. Regardless of what happens in the exam, I think these two, if you're thinking, oh, I quite like computer science, it's worth you having a look at those two strategies. If the exam board asks us to do a different shuffle in the exam, they've got to give us an algorithm for it. You know, I just can't see how they'd expect you to problem solve this and implement it in the time. But a little bit like the Fibonacci last year, they could give you a little algorithm that would allow you to code it, and Riffle and Fisher-Yates will be possible ones. There's not loads of others, but there's a few others. Mainly because I'm going to give you a solution to Riffle Shuffle. I think it'd be a really, really good one for you to try. I particularly like it because it's of the divide and conquer style of algorithm. Although, you know, if you wanted to find out more about this, there's a variety of papers about its effectiveness. Look at the Wikipedia article. There's loads of bump about how the fact that 7 riffles randomise it, and there's loads more that say that's a load of rubbish. It's quite interesting to see the academic debate about this. The basic gist is, if you don't know what riffle is, you're going to cut the pack, and what we're going to do is we're going to have 2 arrays, both of type T card, and we're going to call one left, one right. So this is basically the 2 halves of the pack that you put into each hand. Then effectively you sort of let go of each cut in turn, so left, right, left, right, left, right, left, right, left, right, and put that back into the deck. So this is a perfect riffle, and this is roughly the pseudocode for it. I've written this in VB, but I don't want to give you the VB straight away. So basically, for each position of the deck, that's 52. You're going to say if it's an even number, and you can obviously use mod 2 to work out whether it's even or odd, then you're going to put in a card from the left cut, and if it's a right number, you're going to put in one from the right. Now, basically, you're going to be placing this in the position that's being counted in the for loop, but the problem is the position of the left and right cuts don't go up one per position of the main deck, because there's 2 of them. So you've got to have this offset position where have a look at this, just dry run this, and you'll see that these 2 negative offsets basically sort of ensure there's parity between the relative position in the left and right cut and the deck position. so that you're always taking from the bottom of each cut effectively, or actually this algorithm takes from the top of each cut, of course. As it happens, if I just do this, I get really rubbish randomisation. At the very least, you sort of assume that you're going to do what's called an in shuffle and out shuffle. So this always goes left first, but you'd probably want to do it so that you, on the first shuffle, go left. On the second shuffle, you would start with the right. In testing, that's given me pretty good randomisation, certainly after 10. It's not great randomisation, obviously, after one shuffle, but you know, this is a nice algorithm. I like it. This is effective after one shuffle. Literally, it's quite similar to the one that the exam board have given you in the code. But rather than just swapping to random positions, we'll go through systematically and make sure that every single card has been swapped with a random position once. There's a few flavours of this, and the one that I'm showing you is the Durston field. Oh, I think I missed out an I actually in this name version of this, and even from that, I think there's different flavours gone off. So basically, for each card in the pack, in this particular one, I'm going from the back to the forward. What you do is you generate a random position and then swap the current position here with your random position. The random position can either be selected from the whole deck or just from the unswapped cards. Again, swapping from the front to the back and back to the front alternately, if you're going to do multiple ones of this, might be slightly better, because especially if you're going to only go for the unswapped cards, this last loop is basically rubbish. It just doesn't move. If you're swapping it from anywhere in the deck, then it becomes a little bit more useful. And this is an effective shuffle with literally one sweep through the card deck. Obviously, its limiting factor is how random is the random number generator that you're using. Save a deck state. So we've currently got one deck state saved. It might be that another way of solving this problem would be that you do really, really good shuffles and you save a dozen deck states, and you can either use those deck states to test because you know the order of them, or you can just select from those different deck states in order to create an impression of randomness. I guess you could also start from a random position within the deck and loop round. But anyway, let's not get carried away. This is fairly straightforward. New procedure called save deck. Pass the deck to it. Open create a file, probably either a specific file name or a file name system, and then use a for loop just to print each row of a deck. Close the file. Job done. We now get to something that I don't think is going to come up, but that doesn't mean it will. It won't. Just because it's, I don't know, it might come up. I don't really think it will. Trying to somehow assess the randomness of the deck by sort of finding out how many adjacent cards have the same value. I mean, it's easy. You have a simple loop and use some kind of gather variable, and you just use your Boolean statements to see what you're gathering. And it could be the same rank, so 2 2s, for instance, like in the test deck, or maybe how many cards of the same suit have you got that are adjacent. You could look for runs. You could look for something else. The only thing is, if you're going to do anything with this, it gets really tricky really quickly. Basically looking for the mathematical distance between a particular deck state and an ordered state is not easy maths. I've had a little look around to see if there's any simplified algorithms, and there isn't really. So yeah, we'll look at it, because I think it's quite nice sort of thing to do. But we'll look at it. I'm running out of things to think of to do with the deck, and this is something a few people have suggested. It might come up, and certainly looping through and gathering is a nice thing to practice. Working with non-standard decks, I thought this was a really good idea until I've started playing with it. Multiple decks, basically creating a larger array of records, and then loading, simply loading the deck twice into it is quite easy. Or if you're doing something else, if you're generating your deck, then generating it twice, but just having a larger array. It's reasonably straightforward. You do end up changing a few things around the code, but that's okay. It's nothing too bad. Anything else, like just having one suit or adding a new suit or just number cards, starts to become a bit of a pain. It really does. I think for the quality of, I'll play with this a bit more to see if there's a nice way of doing it, but certainly for the sort of quality of them testing your understanding, it seems like a lot of faff and a lot of time for not a lot of nice algorithm, really. So, I want to have a look to see if there's some nice ways of doing this, but I think there's not a lot you can do with this, really, because you've got to be generating your own deck, because of course the deck file doesn't have any of this. So it's not ideal, really. It's got to be combined with generating your own deck and then randomising it. Right, that was my ideas for the deck. Some really good things for you to go away and try. Obviously those shuffles I've given you the algorithm. For the other things I've just given you little hints on the strategies. I'll be posting solutions on these probably sooner than some of the others, because I think it's some of the most interesting stuff here. I've not actually seen anyone else talking about shuffling yet, but I'm sure people will come round to it fairly soon. I really hope you enjoy working with these. There's some interesting stuff there.